Oh, I got it correct.
Wonderful. Wonderful. Okay. This happens all the time. Look at the steps one more time. I I know how good you are, Nicholas. You are good. I do not want you to ask every time you see this. You are this good. Are you comfortable with your steps?
Mm,
Because right now, you're more focused in presenting. So, can you look at it and say, are you comfortable with all this? Or do you notice that there's something that is just bugging you?
it was like I completely forgot about square roots and how they work.
Okay.
I forgot that you could just get rid of this. I was just thinking of something else.
Yep. Yep. Okay. So you sure you settled that problem?
Yes.
Looks like the question 4 will be the same thing. Looks like.
Sure that d dx can be expressed in the form.
Okay. The three exceptions and the three rules. What do you notice?
Wait. First, let me just put it in the way there. So now I can just
Wonderful. Okay, which rule do you want to use?
quotient. So I will use u prime v first.
Oh, your
V.
setup is not good for quotient. Your setup is for product if you put it in -1. If you put it in -1, you're basically declaring you want a product rule. If you don't do the -1, you leave it in fraction. You want quotient rule. Do you understand what I'm saying? I never taught you this before. Your teacher should have taught you this. If you don't understand, tell me.
Is it because you have to do a fraction of the denominator times squared?
I mean, for a quotient rule, you need a denominator lah. Correct or not? That makes sense,
Yeah.
right? But for a product rule, you can actually change the denominator into power -1 and you pretend there's a product
Why
rule. It
can't I
will
just
absolutely
do
work.
it like this and then like put it as a fraction back when I put quotient?
I you will see if you don't understand why that's not okay, yeah, then I will ask you to practice that right now, but use pencil.
You know what? No, no. Yeah, I
Look, if you don't see why that would be wrong, you must use a pencil and try today. You must try today because there's time. Your question is valid, you see. I want you to answer it.
let me put these parts in non-bend
But pencil,
first.
please, yeah. Pencil, please, yeah.
Yeah, I'll
Pencil.
put the u prime, v prime in bend first.
Man, Nicholas, you're very how do I say, you're very hard-headed lah. You do as you wish.
Then now use pencil.
Do as you wish, Nicholas.
Why did you put d dx, not dy dx? Is it because no y?
The Y is that thing, man.
There.
Nicholas, since you do not hear me just now, I tell you you must bring this to completion to see whether you're right or wrong. You must finish it. Try your best to do what they want lah, so to speak lah.
Okay.
Okay.
I mean, you're currently saying the answer wrong.
Yeah, I've been saying that from the start, Nicholas, and you're hard-headed. Now you bring this to completion because
I mean,
you
I
need to
guarantee
know
that I
why.
cannot because is this 2x minus 1? I have 4x.
Okay, so what do you want?
I don't can't do it anymore.
I will show you two ways. I'll show you the product rule way and the quotient rule way because I suspect your teacher will be discussing both of them. I'm guessing lah, so that there's no confusion. Yeah. Okay, both are valid. Oh, so sorry. Oh, sorry. That's bad. Product rule first or quotient rule first?
Quotient.
And then just continue normally, you'll be fine.
Mhm.
You figure out the difference between my setup and your setup, and you figure out whether I am right or wrong also. That's your job.
Oh, the difference is that you just left it. Okay.
Now, this is the product rule setup. I'm not saying that what I'm doing makes sense. Yeah, it doesn't make sense. I'm just following the rule better than you. I admit that. I'm not doing anything which is wow, such a great thing. No. I'm just following the rule. Now, the product rule setup, which your teacher might have done. That's why you're doing that. Maybe, I'm guessing. Now, this is your setup, and I'm okay with that if you're using a product rule. That's your U, and that's your V. Now, your U is that, therefore your U prime is an X. Your V prime is minus 1, 4x minus 1 minus 2 times 4. Do you understand? Do you understand my setup for product rule?
Uh-huh.
You sure? Okay, this is now different from you. Both my setup are just simply different from yours. Soon.
The
Soon.
thing
Yeah.
is, uh, hmm, yeah.
Soon it is different. Right now, it is still the same. See, my V prime is the same as you, right? So you're doing something right. But after this, I will be using product rule lah, which is now different than you lah, of course. Then I'll be doing 10x times V. V is, 4x minus 1 minus 1 plus U, which is 5x squared, times the V prime, which is in this case minus 4x minus 1 minus 2. And then I have to rearrange. Both will actually give me the answer. Both. Okay. Are you okay so far with what I'm saying?
Okay, so the mistake I made is that the V is stays like that. The V is from the fraction.
Your setup is product rule, you use quotient rule. Your setup is, you're not setting up for the quotient rule, you're setting up for the product rule.
Okay.
Do you understand what I'm saying?
Yes.
There's a second teaching I have never taught you before. Obviously, you have to choose quotient rule or product rule as your first try. Obviously, you have to. Now I have done the hard work of presenting both to you. Can you tell in this case which one is the better rule?
I can tell that the top one is definitely the better rule
Why so?
because they want in 4x minus 1. Actually, 4x
Correct.
minus 1 is
Correct.
more important.
Because they give you the answer key. Now, what happens if you do not have an answer key? First, you have the freedom to do whichever you do. You also have the freedom to end the final answer in whatever manner. And I can tell you, most people don't like quotient rule. But there is no reason why you hate it. That's not a good reason to hate a quotient rule. Okay? Even right now, quotient rule is a better choice because they give you the answer key. If they don't give you the answer key, this is advanced level. I'll just FYI you first. The advanced level, the appropriate thing is to look at the next step. An exam question is rarely just this. The next step, hey, which one will be more beneficial, product rule or quotient rule? That would be the right thinking. Right now, you cannot do that. Just saying. Do you understand?
Mhm.
Now, your choice. What do you want to do?
I'm gonna do quotient. Anyways, I need to practice it.
Yeah.
So
You will
that
do the
might-
algebra afterwards, yeah? Now, can I don't show me my working? Can I do that? Can I just close it?
yes.
Yeah.
And yeah, get rid of that.
Hey, do your setup first, please. Where's your
Okay.
V prime?
Huh? I already put it. Oh, you can't see.
I can,
Yep.
okay, now I can see. Good, good, good. Okay, now you do a proper rule. Wonderful.
Now I need to do 5x. Yeah, no.
You good? Now, this should be easy.
Forty x squared minus 10x minus 5x minus 28. And then I just have to, yeah, do that. How many times? Okay. Hello? Hello?
Yes? Yes, you're saying? You're saying? You're saying?
Okay. Sorry.
Can you finish that? It's important to finish it.
Yeah. I just, I was just doing something.
Sure.
Now let me just, uh, 10. Eh? Actually, no, wait. Let me just make it easier for myself. Ah, okay. This, right. Okay. Ah!
Okay. Can you finish it up?
Sorry, teacher, I sneezed and it's made a mess.
Go ahead. Clean it if you wish. Yeah, of course.
Okay, well, I think I'm done.
Okay. And then, okay, wonderful.
Yeah, okay, cool then. Yes. Well, I need to remember that they're not the same. That is similar. Quotient rule and product rule are just similar, not the same.
True. And the setup is different.
Okay, then.
Okay. Looks great to me. Now
Okay,
let's
now
look
the
at
last
question
question.
5. Right. Hey, more of the same, right? More of the same. Now I'm gonna stop you here for a while. This is the first exam level question I've seen. Why? There are at least 2 steps. Look at the first part. The first part, you're familiar with it. They give you the answer key. Am I correct?
Mm-hmm.
Do you know why they give you an answer key in an exam level question? They say, I want it this way. Why? To make your
When
life
you
more
mean answer
difficult?
key, you mean in the question, you mean this one.
Correct. They don't have to give you that one. Let me repeat it. They do not have to give you that. They just say, hey, dy dx can what? Why do they give you this? Is it to limit your options, to make your life harder? What is it? Why? Do you know why?
Make sure that you understand.
Well, if you're saying that they are being helpful, you're correct. Is that what you're saying?
No, I'm saying like make sure that you understand how to move it. Like just not just differentiation, not to like
No, no. I can tell you the exact intention they have in mind if this is an O-level question, because this is an O-level question. They give you the answer key because that is the best thing to do moving forward to be. If you do not have that form, for example, you do a product rule, your format is different now. Let's be fair. And that's okay. They'll still give you the marks. The problem is in part B, things will be harder for you. They are really trying to help you here to make sure that you have a smoother thing going to be. That is their intention, and it is never not that. It is always their intention.
uh,
Do you think that question makers tend to make your life more difficult?
no.
If not, then it will be easier for me to ask you to trust their intention in helping you. I'm not joking. They are trying to help you.
I know. Because you need that one for next question.
And that is the best way to do it. Lah. Because there are other choices in part A and they don't want you to take their choices, makes B harder. Lose 2 marks or something like that. Okay. Give it a try and hopefully you will get B also. Then you have a first exam level experience.
Okay. I'm assuming I have to get y prime and x prime, then get put in whatever.
Wait, what happened to your rule? You know, the basic, the 3 exceptions, and the 3 rules. None of that matters at this point. None of that.
Hmm.
Is that we're doing something totally different?
No, wait. Do I want to do quotient or product? I don't want to do quotient or whatever.
Look at the answer key lah. The answer key kind of hints you, hey, maybe, you know. Maybe.
Then we'll do quotient.
Okay, not a bad choice. Set it up, please.
So u is just x and u prime is 1. Yes. V is 6 minus 7 half. V prime is half 6x minus 7 half 6. So it's going to be 6x minus 7. Okay. And then I have to put u prime. How? Teacher,
Mm-hmm.
may I ask, right?
Yeah.
When they do that, the denominator is squared. Is it the inside of the denominator or even the square root, even has to be squared?
Sorry. Would you please point to what you're saying? What point to?
Because in the quotient rule,
Yeah.
the denominator has to be squared as well.
True. V squared, lah, right? Yeah, you want a V
So
squared.
I'm assuming I have to do what is this first. This
That whole thing, yeah, the whole denominator, and then you just square it, lah, which is not a difficult thing, if that makes sense. It's not, right? It is not at all.
so it just becomes 6x minus 7.
Correct. In general, that is the right conclusion. The answer key is being a bit more specific, but you are not wrong. You're not wrong. So I have faith.
Okay. Well, top part is just u prime v, but u prime is just 1, so it's gonna be 6x minus 7 half minus x 3 6x minus 7 minus half. There. Then we just that. Uh, hmm, uh, and then this one has to go down. Uh, wait.
Give me a minute, Nicholas. Sorry.
So, mm, 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 mm.
What happened here? Your setup is gray. Your setup is gray. So that means your differentiation is gray. There is most definitely a problem afterwards. That means you're doing something that you're not supposed to do lah. Most definitely not supposed to do. Oh my goodness. What? What is going on here? Oh, no, 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 no. That's fine. No, still you're doing something wrong. Still you're doing something wrong. But your differentiation is correct. Do you understand, Nicholas? Your
Uh,
differentiation is correct. It's always the algebra afterwards. That's the usual problem for everybody also. Okay? Clear, yeah? Now, I'm going to follow you on that. So what you're saying is this. All this half and power minus half is indeed very confusing. Just put 3 over there, right? And 6x minus 7, and this is power minus half. Now, over here, at this point, this looks to me like 6x minus 7. I'll just write down that way. Can? Can?
yeah, yeah.
Your next step is wrong. Your next step is something like this. You have a fraction here. I agree. This guy is a fraction. This guy is actually 3x over root 6x minus 7, correct?
Uh,
You have this guy here minus, and then you have this whole thing as 6x minus 7. Now you basically move this down without any justification at all, and therefore you're wrong. Do you understand where you're wrong first?
yeah,
It's
yeah,
very
yeah,
dangerous to not do that.
yeah, yeah, yeah.
Okay, okay. Then you cannot do the second line. Okay. One more time, not a differentiation problem. It's an algebra problem. Now, what can you do? What must
Move
you
it
do?
away and try
Um,
to like simplify. I'm working at both denominators the same.
what? Okay, I'll give you the hint. I'll give the hint, right? They seem to be telling you, hey, the square root will be present. And at the start, you may think that that's a joke. It wasn't. They are really telling you that, hey, 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 the square root will be there. Although there is nothing wrong with this and there's nothing wrong with that. That's my first hint to you. Do you understand?
Uh-huh.
Then do you understand what to do?
Um, is it not what I just what? Huh?
Okay. So I'm first of all, in an exam, I'm asking you to trust them. Hey, if they say the square root will be there, chances are the square root will be there. And they're not trying to make your life more difficult. They wouldn't. They wouldn't. They're actually telling you, hey, just be careful, friend. Okay,
Okay.
it will be there. And now my additional hint to you is that this is correct and this is correct. There is nothing wrong with that. But still, the square root will be there afterwards. You get anything from that hint?
Okay. Okay.
Okay, then if you get something, can you do something? I don't know. Can you?
Okay. Wait. Can I just wait? Let me try
Use a
this.
pencil. Use a pencil. Are you using a pencil?
Yeah. Yeah.
Very good. Okay. Okay, try
Mm,
something. I like that word. I like it a lot.
this one. I hope this.
Okay, that can stay. Yeah, that can stay.
There. Is there something I can do?
You are just doing the same thing. You are doing it wrongly. No, you're doing it wrongly. You're doing it wrongly.
What?
Now, don't do anything. Don't do anything. I don't think you understand the algebra part, the fraction part. That is what is worrying, and we have to address that. Now, I'll show you an
I
example.
can't just move it down. I thought you can.
And that's the problem. That's the problem. I don't think you see that this is a problem. That means you're going to repeat it. I'm trying to solve that problem right now. The problem that you don't see it as a mistake. Yeah, wait, just wait. Now, I'm going to use simple numbers. Let's say this is 5. Let's say this is 2. And this is, say, minus, I don't know, 3 over 7. right? Okay.
Mhm.
Okay. This looks similar, right? This looks similar. Okay. Okay. Now you're saying that I can do this lah. Basically, that's what you're saying. What?
Okay.
And can you see that that's wrong?
Yeah.
Okay. The first thing you do, though, you also must see that it is wrong. This is very important. I'm not trying to say, hey, Nicholas, you're not thinking. No, no. I'm really saying that this is a problem that will happen in exam if you don't attend. The first thing that you do is this. The first thing that you do is, oh, you do this. 2 minus 3 over 5 times 7. That's the first thing that you do. Do you see that that might be a problem?
Yeah.
That was the first thing that you do. Do you
Yeah.
see that?
Yeah.
Okay. And again, do you see that that is clearly a mistake?
Yeah.
Now, with the help of this simple number, tell me, what are we supposed to do? Just look at this simple example and you should be able to know what to do. What are we supposed to do? Please think only using these numbers.
Uh, the bottom must multiply the 3.
The bottom must put your Okay, could you just copy these numbers and do what you think needs to be done? Just try first.
I don't remember. I don't know how to use 3. What?
Are you serious? You're saying that you do not know how to do this.
3
Are you
fractions.
sure about that?
Do I have to put the 7 in the bottom while having also 7 times 2, 7 times 2 over 7?
Look, can you just do something? I'm serious. Can you just take your pencil, copy this number, and try to do something so that you can see for yourself?
Am I right?
What you are doing is excellent, I would say. What you're doing is correct. If you press the calculator, it will be correct. Now, does this help you in any way?
Yeah.
Okay, give it a try. Always knew you can do it, okay?
Okay. Uh, yeah.
It looks good to me. Looks very good.
Uh, that would be like, yeah, that's definitely correct.
It looks great. It looks good. Oh, you got it. You got it. You got it. And you are correct. You have the answer key. Nicholas? Are you clear? Your differentiation is correct. Your problem was algebra and you did solve it yourself. You clear?
Yes.
You expect this in exam, okay? This is exam level question. And you have the skills. You do. You just have to do it correctly lah.
Oh, yeah.
You do. You do have the skill.
Yeah, well, teacher, I'm not done yet.
No, of course not. But you get your 4 marks.
There's still one more part, and that is the second part. Find the exact coordinates of the point in which you create. Well, I already have this one. I can do this one equals 0. And since they help me, it means that this is definitely the one I have to use to equal 0.
Okay. Give it a try. All right. Yeah. Nice. Okay, then what do you do at this point? Oh, your teacher have taught you this, isn't it? Oh my goodness.
Ah, I'm very stupid.
Maybe, but you can correct it yourself, and therefore you are not that. You're quite smart if you can correct it yourself. That,
Uh,
that's okay. That's enough. If you can correct it yourself.
oh wait. Okay, wait. Let's just let me. Okay. Well, that is definitely wrong. Wait,
Come on,
I'm gonna
proper
go with
door. Thank you very much. Proper
this.
door. Now, is this the end of the story?
No,
The exact coordinates?
it's not.
Okay. What's missing if there's anything missing?
I need to get a Y.
Okay. Definitely the right thing, but how?
I can sub in from the very original, the original one,
Why don't you sub it into the dydx?
because it's you have to do that because that's like what you have to just do.
No, I expect a better understanding from you. You are a smart
Because like
person.
it's the most accurate one. Like just in case
Well, dydx don't give you y. Make sense or not? Dydx give you dydx lah.
Oh yeah.
Dydx give you
I
gradient lah. But
don't know how to explain
people
how
do that in exam,
it's
Just
because
because.
I just think that
Mhm.
the the original one is the most accurate. So
The
yeah.
original one gives you y. Okay, if you can say it that way, lah, that would be kind of nice. But okay, you got it right. So go ahead. Okay, get a 2 marks.
Bruh. Okay. Uh, let me just grab it in. I don't like that. Uh, if only calculator will give me like the actual number and not as a bunch of fractions. I know this should be a number.
Your exact coordinates. So using a calculator will backfire. Probably. Probably,
Yeah,
lah.
yeah. The
Probably.
thing is,
Exact coordinate.
how would I? Hmm,
This is
okay,
an
no, I just need to
unexpected.
like
I mean,
actually calculate this.
oh, this is an unexpected problem, isn't it? Oh, this is unexpected. They're giving you a lot of problem in the third form. Wow.
What if I like do y
Wow.
equal x, but then I simplify first that one so it's easier.
Now in exam, I'll ask you to abandon this first lah. It's not worth the 1 mark. It's really not. Okay. The calculator also confirmed to you that the answer is not very nice, man.
No, no, no.
Wait a minute. I think the answer is nice.
No,
What's
the
wrong?
answer will be nice. I know the answer is nice because yeah.
Ah, okay. That means we have a revision for cert, so might as well, right?
No, the thing is right. I think I can just do y. You know the original equation. I will simplify that one. It'll be easier for me. I can do that.
Hey,
I'll
can
just
we just do it for you for now? It's a cert revision. Can we? It's a good revision. You will need this revision. Would that be okay?
yeah.
Okay. Observe the cert. So you have 7/5. Am I correct? Sorry,
Yeah.
7/3, is it?
Hey, five?
Seven-
No, three, three.
Okay, okay. 7/3 on top, which is great. And then the bottom one, I think you just didn't continue with your steps. I'm not sure why you do not do that. It's quite easy to continue with the bottom one first.
Yeah, yeah, no, no. Yeah, that
Can you tell me?
is something that I need to do, which is actually really, now that I think about it, easier.
Root 7 lah, right? You're gonna write a root 7.
Yep, it's just
Okay. Now you still have to simplify more, but it's not difficult. Now the third plays a part. Do you know how to continue from here? Now this is third. Now this is sec 3.
yeah, yeah, wait. Um,
It ain't that hard, but oh, unexpected problem. Yep, yep. Nice.
3/7. No, wait, what am I talking about? How would it? Uh, wait. Let me try to remember this real quick. I'm not trying to remember certs. I'm trying to remember. It's very simple other thing. It should be
Uh,
simple, but
wouldn't it be easier if I just do it for you first?
yeah,
Okay. What cert hates? I always teach you this. What the cert question hates, you may not hate. That's why I teach you what they hate. What they hate is a denominator with certs. You repeat that for me.
yeah, I know that one.
Okay. Then you may not hate it. I agree. You may want to leave it alone, but they hate it. That's the problem. So, okay. What do you do with a denominator with certs? You simply times 1. Come on. You rationalize, man. And you change the 1 to whatever suits you, which
Uh,
is which is what?
7.
No, root 7 over root
Yeah,
7.
yeah. Sorry.
Okay. Which kind of you just continue from there. Lah. Come on. It's a simple technique. It's a good revision. They hate it. You just give them what they want.
Oh my god. How do you do 7/3 times 7 square? Right? 7 square? Square.
Hey, they hate denominator with certs. Do they hate numerator with certs? Do they hate it?
There.
Hey, what happened to your numerator? What happened to, sorry, what happened to your denominator?
Becomes, wait, what I was saying.
Yeah, yeah,
This
it's
is,
nice. But you need to simplify more. This is nice. This is nice.
mm,
Very, very nice. But you're still not at 1 mark. No, no, no. You're still not getting the full mark.
I just need to remember.
Why is that a 3?
What am I
Why is
doing?
that a 3? What are you doing?
Oh, wait. Wait, let me just. I don't. It's a really annoying cert, man. I hate it when it's three fractions, or the fraction over a fraction over a fraction. I'm
Are you
still.
sure you are stuck? Are you sure
Wait,
you're
wait,
stuck?
wait, wait,
Are
wait,
you
wait,
really
wait.
sure? This is just simple fraction. This is fractions. Yes, your problem is with fractions, but it's also just fractions. Seriously.
I don't remember. Oh my god.
Man, what's going on here? Are you serious?
I don't know what. My brain is like I can't think. I can't remember. I don't know how to proceed. When I see three fractions, it just makes me like
Okay, okay.
my brain stops.
Let's do this. Let's do this, okay? Because we have to settle this problem. We have to. And you have what it takes. Just look at my screen, okay? My screen. We'll start with something slightly simpler, only slightly. Half times 5. Tell me, this becomes?
Uh 1/2 times
Oi,
5 divided by
times
2.
5 is?
5/2.
Thank
By
you.
2.
No need to doubt that. You're correct, okay? You're good. Okay, so you can handle that, okay? Compared to what you're dealing with, I mean, this one is only slightly easier. Now I'm gonna show you another thing first. Okay, so let's say there's a half, and I write the fraction a little bit differently just to not confuse. Let's say like that. Can I confirm what this is? You do whatever you want, lah, but you tell me the answer.
1/6.
Hey, who told you to use calculator?
I didn't use calculator. I just picked it up. I say 1/6 before I use my calculator. I just what calculator
Very
to
good.
check it correct.
Very good. And you will be correct. You are absolutely correct. Now, before I give you more hints, are you sure this is not enough?
Am I assuming you want me to uh
Because you have what it takes, okay? You have. Come on, man. Come on.
am I assuming you want me to do the 7 times square root 7, you put 3 to the bottom?
I mean, the tree is always in the bottom, right?
Wait,
Could you just think
wait,
about this
wait, wait,
example?
we gotta like use my pencil real quick.
You should always use your pencil, yes. There's no hurry with pen.
Okay.
It looks great to me. Can you tell me the number below? What is that number below?
Square root 7/3,
Yeah,
but
why
I
is
made
it
it really
7?
small.
Yeah, how come you write down as 7?
No,
But
square root
your,
7/3.
yeah, but your step is correct lah. Do you understand the steps? Do
Yes.
you understand that you need to do this in exam lah? Are
Yes.
you okay? Are you comfortable? Are you clear?
Okay, let me make it bigger first.
Sure, sure. No problem. Problem. It's great.
It's not bigger. I don't know why, but
No, no,
it
no.
works.
I know that you're correct. I know you're correct. The question is, how clear are you? Can you do this again in exam? You know?
I think so.
Okay. You do have what it takes, okay? It's just that for some reason you're stuck just now. I don't know why. I don't know why. But people do have that problem from time to time. Anyway, good homework. It's clear. Now, I'll prefer to talk about chem right now. Okay, no more
Okay.
homework. You deal with your homeworks by yourself.
Yeah,
Okay.
finish it. I finish.
Any updates on chemistry, please?
Um, there. Um, we are on. What was it? Electrolytic, and basically just going through more electrolysis.
How are you with electrolysis so far?
It's okay. It's just that the charts is so weird.
I
But most
will.
of it is just okay. But
Okay.
the thing that also annoying me is like the equations.
The what? Sorry. The
The
what?
equations, some of them.
Okay, Nicholas, I'm gonna make a decision because we only have 15 minutes. My decision is I'm gonna show you and everybody else also, by the way. I regret not doing this. I should have just shown you the most complicated example. That actually has a good and positive effect. I wish I've done that in holiday tuition. I was holding back. Now I'm gonna show you right now and fish out all the problems you have, and then suddenly, hopefully, everything will seems easier lah, if you understand the most complicated example. Understand?
Okay.
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 You take your paper and whatever, you need to draw something. You need to. Electrolysis is just very too complicated to just look at it. Paper and pencil, please.
Okay.
Yeah, I regret not doing this lah, in holiday tuition. Could have solved our problem. But you have a good school, and that's something.
Okay.
Empty paper, please. Now
This
follow my
is
drawing. Follow my
MC.
drawing.
Oh, electrolysis.
Yeah, follow my drawing. Yeah. Okay. Should have done this for you guys. Good.
Okay. Uh, there.
Okay, the
Now.
most complicated example is where the anode and the cathode, we don't care which one is which. There's an anode and a cathode here, right?
Yeah.
When both of them are not inert, meaning they are not graphite, see, and they are not platinum. When they are not either of these, they are, well, something else that could
Reactive.
participate in the reaction, and that complicates matter. In fact, it complicates it quite a lot. So an example of not graphite and not platinum is as simple
Graphite.
as
That's C.
graphite is C, man. Graphite is
Graphite.
carbon. Graphite is carbon, man. Clear?
Oh, yeah. Yeah.
Yeah,
Okay.
graphite is carbon. Right? So, hey, if it is graphite, thank God. It's simpler. Hey, it's platinum. Great, man. It's expensive. It's still simpler. I love it. It is not. Right now, it is not. So, for example, this will be iron, and this will be
Oh,
iron. For
so
example.
this
Oh,
is
no, no, no,
right.
no. I should actually make it a different method, right? The difference in the metal makes it even worse for some people. Oh my goodness. They are not just not carbon or not platinum. They are now different, really die, something like that.
Isn't it
And
to
it
make
has
it
that kind of
like
effect.
a redox reactor?
Uh, hey, electrolysis reaction is always redox. Hey, hey, hey.
I'm saying like, isn't it like technically wait,
Okay.
electroplating? Wouldn't it be?
You have learned electroplating?
Yeah. If
If you have learned,
the solution is iron, the top one will be electrode.
if you have learned electroplating, then I expect you to catch this very, very fast lah. Electroplating is the most complicated example with the most complicated answer. So let's see lah. Let's see. See. Now, the electrolytes lah. Okay. I'm gonna just say it out as Cu.
The one I have a lot of problem is the equation. Oh no, wait,
Um,
what? So the solution
uh,
is CuCl.
sure.
CuCl.
You say that your only problem is reaction, so write down the two reactions lah. Can you do that?
That's my problem.
Okay, then follow me. I teach you the most important thing is to find out where the electron is going. That's the first thing.
Ah,
Did your teacher
wait,
see something like that?
teacher. Can I basically say the battery diagram, the longer line is the positive
Yeah, yeah,
and
yeah,
the
yeah. Yes. A physics student will know, but you are absolutely correct. It's that simple. And
yes.
that determines the electron flow immediately, and electron flow determines everything. Everything. Makes life
Uh-huh.
easier. Okay. So in the bottom one, you notice that I only reverse the battery, lah, right? Notice that? So
Yeah.
there should be a difference. There should be, right? The battery should matter.
Yeah.
Battery direction should matter, and let's find out why it is so lah.
Yes.
Now, let's call this number one. I will not say whether this is, I'm sorry, no, no, never mind. I just call this, no. Why do I even bother to call it FENC? I just
But I should probably write this
let
down.
FE and HCU lah. No? Yeah, you should probably write down. That is still the most important thing. They even make it into a mark in some questions lah. Um,
I'll say that this is not C,
and
not
not PT. And
it
things
is
are
what platinum.
platinum. Yeah, both are, inert, not
Okay,
reactive.
so I'll write for the two diagrams, the bottom
Sure
and
thing.
top.
Sure thing.
Please don't change.
If you can get both correct, well, you're good lah. You're good.
But then this is also minus plus. This is E minus A. Teacher, that's wrong.
What do you mean?
The bottom one is wrong.
You are absolutely right. The bottom one is wrong. Wonderful. You realize that. Good. Electrons should be coming out from the negative and coming in into the positive. And well done. Good job. Good job. Like it very much. Good. Okay, now, so why does it matter? At least in my point of view, right? So clearly at CU, things will get reduced. Lo. If that matters to you, it's very clear. Lo. And clearly at FE,
U
things
as
will
in
get oxidized.
the top one. Yeah.
Yeah, for the top one. Clearly, because it is forced to receive electron, what else can it do but reduce? What else? What else can it do? Okay.
Hmm.
The bottom one will be different, no? Simple, right? So
Opposite.
clearly, this will be reduced and this will be oxidized. At this point, some people would like to remember what the teacher said, anox or red cat.
I'll never. What does that mean again?
Oxidation happens in anode and reduction happens in cathode. For what I can tell, this doesn't help at all. It's nice, but it's not helpful at all.
Isn't it
But
like
if you
obvious?
want it, to me, it doesn't even matter. What matters to me is that where oxidation happens and where reduction happens. So if you don't think this is something you want to remember, I will not force it to you. I also don't like it too much. So let's forget about that for now. Okay?
Yeah.
Can you? So anyway, oxidation reduction. So why does this matter? Well, the reduction part, the oxidation. I hope this is obvious that this will attract positive stuff and this will attract negative stuff. This should also be obvious.
Yes.
Okay, if this is obvious, good for you because now we need to write a candidate list. The complication of the reaction is not the reaction. The reaction is easy. The problem is determining who reacts. We need a candidate list. Immediately, when you know, hey, Cu attracts positive, immediately you form a list. This is 2 plus and this is Cl minus. Am I correct? So I have a candidate here. The
Yes.
candidate list here is Cu2 plus, correct? Cu2 plus. Cu2 plus because it's a positive. And this is
Yeah.
equals, right? This is equals. So I have a H plus as another candidate.
E-
I do. I do have H plus as a candidate from the water.
yes.
Right now, I have a candidate.
And the
And
bottom is OH minus and Fe. Okay.
this one, no? So this one, the candidates are Cl minus, OH minus lah. Fair enough. Those are the
Yeah.
candidates. Okay.
And OH minus.
And let's be very clear. Cu, you must think about it also because Cu can react, may want to react. Cu is part of the candidate. You must think about it.
Oh.
That adds to the complication, man, because Cu might just win, it might just win. So in this case,
Why do
F
you write two CUs?
is not 2 Cu. Hey, you're a chemistry student. Cu2 plus is not Cu, please lah. Cu2 plus is a metal ion. Cu is a metal. They are different.
Sorry.
Now we have the candidate list. I can tell you later, you will realize this is not even complete, but this is all we have right now. Now, from the candidate list, did your teacher say anything about, okay, who's gonna win? Okay, who's gonna react lah, basically. Do you have any idea how to determine that? Or your teacher just say memorize?
Wait. Let me remember something.
Okay.
I think copper ion.
Copper will, okay, so you are saying, so based on your knowledge, this copper 2 plus will win? This is it, okay, this
I
one?
think copper 2 plus and OH minus.
Okay, okay. Now, let me give you my opinion first, then I'll support it with reason lah. The reasoning is what's important, man. Right? I think, I guess I use a ping. I think Fe will definitely win, hands
Okay.
down. Okay, and for this one, yeah, I believe Cu2 plus will win. So that's great. We have some agreement, but we have some disagreement. Now, I want to explain the reasoning to you so that you're good lah, right?
I never get thought that the metal will also be the.
But that doesn't make sense if you're never taught, because hey, if the metal can react, maybe the metal will react, right? Makes sense. Anyway, what determines everything is the reactivity series, and you know reactivity series. Let me confirm that.
Yeah, but I'm not good at remembering.
Okay.
I can partially remember it, but I can't tell if it's like based on.
I teach you immediately how to remember it, man. So CH triple dot triple dot triple dot. Understand?
Oh yeah, 1, 2, 3 on top.
Group 1, group 2, group 3, which makes a lot of things a lot easy. And then the middle guy is the most important metal, Fe. So happens is here, this is zinc and this is Pb, something to remember. The rest is Cu.
It's Cu,
Cu,
silver,
and
and gold.
However, I teach you more than that. I teach you more because it's much more sensible. And if you go to JC, they will teach you that. Okay, so okay. There's a mirror image. There's a mirror image of stuff here, which is the mirror image of the stuff on top. That be okay? But all these are positive ions. So for example, this is an Fe3 plus, just saying. Would that be okay?
Oh,
Mirror image is the important thing.
yes.
I do not know why teacher don't teach this. I don't know. This makes life so much easier. There's no
Is it AN?
which AU gold mass
Didn't look like it. Oh,
AU, and you have the mirror image. Please put the mirror image. Please give some space.
okay. Well, there is.
Okay, and then there is
H
another.
plus. Oh, wait. Let me just give it. C. What is it? C plus 4 plus.
Because whatever is below the mirror image is the positive ion of the guy on top lah. So just for now, just assume that it's C4 plus. Sorry, give me a minute.
Okay. Hey.
Sorry for that. Okay. Now, on the right-hand side, I prepared the other reactivity series, which you need also. That's the negative one. Or sometimes people call it, this is the metal one. I'm so sorry. This is
Oh,
the
wait, I
metal
need to.
reactivity series, and this is the non-metal reactivity series, which of course gives you positive ions and negative ions. You need both of this anyway. This is electrolysis. You need a lot of things.
My pen broke.
Do you, your teacher should have mentioned this kind of thing, I guess? No?
The metal, non-metal. Yeah, I know
Both
about this.
reactivity series. Okay, so to complete it, you'll see your OH minus here, then your I minus, your Br minus, your Cl minus, and your F
And
minus.
technically, you shouldn't just call it non-metal because you literally have carbon and hydrogen there.
Correct.
Nothing.
You're correct. And you are absolutely correct. And they kind of cross each other, but only carbon and hydrogen has the ability to do that. So it's not like everything can do that. Okay. Again, the non-metal one has a mirror image, so you gotta respect the mirror image also. Now, only with these two things, the explanation is hopefully super simple. Hopefully. Are
Okay.
you ready? Okay.
Oh, yeah.
Now we look at the candidate for this guy first lah. I'm just choosing it randomly. Now, Cu2 plus is not here. Please understand this is not Cu2 plus. That's not Cu2 plus, okay? That is not Cu2 plus. The Cu2 plus is here. There, I've identified the first candidate. There you go. Okay, you got? Okay. I've identified the second candidate, which is not here. I'm just saying it's not. It's not H. It's H plus down there. Clear?
Yeah.
Okay, clear. And then the last candidate is Cu itself, which therefore, I have I have my three candidates identified. Okay. Okay.
Mm-hmm.
Now, the request is to reduce. So when Cu2 plus reduces, let me confirm, it goes up. Let me just confirm that. When Cu2 plus reduces, it will become Cu lah. There is no other way. This is correct?
Uh, Cu2 plus.
Yeah, reduces, right? That's the request from the battery. So Cu2 plus will become Cu lah. That's basically what it means lah, if it is going to be reduced. Is this correct or not?
It's gonna become 2 plus if it's reduced.
Hey, it from 2 plus, it becomes no longer 2 plus.
Oh yeah, then that's correct.
That makes sense. Okay. And then H plus will become H or actually H2 lah. Just say it's H2. That is if H plus is reduced.
Okay.
Immediately, just from this jump up, you must understand that jump up represents effort. Bigger jump up, bigger effort needed lah. Obviously, just from this, H plus is not gonna win. Obviously. This is obvious. Can you see that?
Uh-huh.
Okay. Now we are left with Cu2 plus and Cu. Now, of course, the answer is already correct, so you don't have to worry too much. Good for you lah. I'm just saying Cu2 plus when reduced, it will become Cu minus, correct? Which is not going to happen at all. Not in a million years. Cu will never become minus. Never, never, never. So Cu2 plus wins. So far, so good. That's just the explanation. I will go to the next one. This one clear because you're correct, man.
Okay.
Now I will explain this one. This one will give you the full benefit. Now, where is your candidate? Cl minus, which is down there. OH
If I'm
minus.
correctly, wait, which one is the ease of reaction? Ease of this.
Yeah, it's pretty simple, right? The
If
bigger
it
the effort, the harder it is. The
if it
bigger
goes
the effort,
if the top left, if it's the more it goes down, the easier it is to react, right? So I
You're
see
not getting something. You're not getting something. Let me show you. So the green candidates are here, here, and here. Did I identify them correctly?
the green candidate.
Yeah. I have Cl minus, OH minus, and Fe lah.
Oh my, can you remind me again why is it called the green one?
No, I'm just color coding it lah. Okay. Okay. I'm just color coding it and just finding it in the reaction.
Okay.
Would that be okay? Now,
Alright.
the oxidation will simply mean this becomes that, this becomes that. That's your oxidation. And to be clear, when Fe is oxidized, it jumps down. That's different, correct?
Yep.
When Fe is oxidized, he's jumping down. Now, jumping down requires no effort. In fact, jumping down is effortless, or rather, it even gives off energy. So among these three candidates, OH minus need to jump up a little bit. That's your candidate. You chose OH minus. It's not a bad choice. Cl minus will clearly lose based on how far he must jump up. Son, I can see you. Yeah, just give us some time. Do you understand, Nicholas? Your choice is not bad.
Uh-huh.
But your choice automatically loses to mine. Fe does not need to jump up. It jumps down. It jumps down. Nobody can beat that. Fe will win. Hands down. Because it's jumping down. Because it doesn't require effort at all.
Jumping down, like so. Uh. Okay.
Okay?
Okay.
Your teacher will explain
The
it differently.
closer
Yeah?
it is to the center, the easier it's get.
Well, a bigger jump down is even easier lah, if that makes sense. A bigger
Okay.
jump up is even harder. You have to see it that way. That makes some sense, I hope lah. So you have
Uh-huh.
choices of jumping down. You must choose the bigger jump down, no? Something like that. You have two choices of jumping up. You must choose the smaller jump up because it takes both, less effort. Hope that makes some sense.
Yep.
I haven't put it in good words, nor am I interested to do that. Now, I'm interested to give you, this is the reasoning. This reasoning always, 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 always works. You will never be wrong. Never, never, never. Okay.
I'm good.
Time is up though. Time is up. So I will have to continue next time. I think we still have to talk about this. That be okay, Nicholas?
Yeah.
Good job for today. I'm quite happy with your progress. I'll see you on Wednesday. Bye.
Bye.
Seven, can you hear me?
Yes.
Wonderful. Seven, have you had your dinner?
Huh?
Have you had your dinner?
Yeah.
Wonderful. How are you doing?
It's all right. This few weeks I'm like really tired because it's competition season.
Tell me more. Tell me more. Tell me more. Seven. I want to know everything. Tell me more about the competition.
Like volleyball, so we got more training and like I don't know, I'm just more tired, but like it's still good.
This is 3 days per week training, isn't it?
Yeah. And like today I just had competition today.
Hey, the competition started already, really?
Yeah.
So Sean, tell me, this is serious. I had a lot of students which are reliable athletes, and therefore they are under an obligation to participate very well. I don't mind, but I need to know. What is your expectation? What's your team's expectation?
Like for CCA.
Yeah, regarding this whole national competition, what's the expectation?
I mean to win, I guess.
Oh my goodness. I
It's
always
just
get that kind of student, okay? Oh, basketball, oh, must win one, Oh, floorball, oh, must win one. Now volleyball also must win. Okay. And you're saying that you must win the nationals.
I mean I don't know if we're gonna win, but like we're gonna try to win. Like right now it's just zonals, but we
Okay.
must win zonals.
Mm-hmm.
But it's not that hard. Yeah.
See what I mean? That kind of school, is it? That kind of school. Okay. Going for nationals, okay? Going for championship. Going for the trophy number one then. And draw for your
Yes.
trophy. Okay. Now, you in the team, what's your role?
Like the position I play,
Okay.
or
What's the
like
position?
I don't know, I'm like
Sure.
the libero, I'm the vice captain.
No. And oh, right. I have an impression that you are not very tall. Apologies, son.
Paul, oh yeah, I'm like normal height.
Oh, you are very good libero.
Uh I'm like a normal. I don't know.
Hmm. I can tell libero works twice as hard, lah.
Oh, I guess.
Yep. And that's why you're tired, right?
Yeah.
Now, that's the team's expectation of themselves, right? And the team's expectation of you, lah.
Mm-hmm.
Now, how about you? What's your expectation?
Um, I, like I don't know, the same to win, I guess, hopefully. I mean, as long as we play our best.
Excellent. You have a specific goal for yourself and for the team?
Like, I mean, I don't know. I don't think we're gonna win nationals. Like, I just want to win almost.
Come on, tell me more. Tell me more.
Cause like we had like 1 year or like almost 1 year that like we barely had training, cause we didn't have any coaches. So like we're like not as strong, but like hopefully we'll still do well.
Mhm. Tell me about the coach issue.
Like I also don't know, cause they like when like my batch joined, then they like I think one of the coaches retired, so like we didn't have a coach. Then when we finally got a coach, then like something happened to her, so we had to like wait for a new coach.
And you have to wait for almost 1 year, really?
Like I mean not 1 year fully, like when we joined it was like a few months, then like in the middle was another few months.
Then what do the team do when you are coachless?
I mean like we just do ourselves. Like there was like one period of time it was the seniors like the sec fives who
Yeah.
like help us, but like that was kind of useless. And then at
Yeah.
one point it was like the teacher in charge. I mean, she used to play volleyball, but like I don't think she was that useful.
Okay, okay. So you're saying that the team still wants to win despite all this?
I mean, like I mean the obvious goal would be to win, but like at least zonals, because we're like zonals we're probably still gonna win, but I don't know about nationals.
I mean, what's the tradition here? Your school is so good at volleyball, something like that?
Yeah, it has like a strong history.
Mm-hmm, mm-hmm. Hmm, Hard to say no lah. To say. Hard to say. You're the athlete in the family, something like that?
I don't know, my sister is also sporty.
Okay, okay. All right, got it, got it.
Yeah.
Okay, glad to know. I always have to, I always have to balance lah, balance, or rather, never mind, never mind, never mind. I'm glad I know right now. I'm glad I know.
Mm-hmm.
Now, Sean, I'm your O-level coach, right?
Mm-hmm.
If that is your expectation, lah, if you just want me to talk about per subject, then I'm okay. But right now, I'll just tell you straight. Um, Coaching one subject usually does not mean an increase in L1 R5. Let me state this again. If a person, no matter who that person is outside also, as far as I can tell, if they focus on one subject only in coaching, it does not mean an automatic L1 R5 increase. As far as I can tell, most people want an L1 R5 increase. It's not just they want a subject to be better, as far as I can tell. Let me give you an example. Let's say you focus on chemistry, right? And it's normal to just go to chemistry tuition. If the chemistry goes up, there is no guarantee that everything else stays the same or also go up. it is possible that something else goes down as a result. And this is with hard work in chemistry. That is, I think, a very common experience with most people. Now, you just tell me if that is not your experience. I'm talking nonsense already.
I think it is.
Right? This is not an uncommon experience. So that might actually happen to most people. Correct or not?
Mm-hmm.
You focus too much on one thing, you are unbalanced in other things. You play a team sport, you should understand that better than most normal people who doesn't play team sport. There is no point if there's a gaping hole or gaping weakness in your team. The enemy just attack that lah. In fact, your
Mm-hmm.
job is to plug that hole, isn't it?
Yes.
If there is a hole, you are going to spot it. You are going to go there and you're going to make sure the team doesn't just kena smack pop. Okay. So it is very important for a team defense to be balanced lah. Now I'm talking about the same thing as your L1 R5 coach lah. If that's what you want me to do. If what you want me to do is to focus on one subject, I'll tell you an almost sure way that your L1 R5 will increase. Just now I'm telling you, most of the time when a person focus on one thing only, they become unbalanced. That makes sense to you. Now, if everything else is good, so everything else is good, only one thing has problem. Focusing on that problem, because there's only one problem, will most definitely lead you to a L1 R5 increase, but only because everything else is steady. Meaning, if you have more than one area of problem, it is not, the strategy cannot just be address one problem and everything else will improve. Cannot. Obviously, you have two areas of problem. And yeah,
Mm-hmm.
okay. Now, which one are you, son? Based on your, overall study L1 R5, do you just have one area of problem, or you may have, well, more than one?
I think it's more than one.
All right. If you're happy, you don't have to decide right now, but this is what I say to all my students. The reason why I am effective is because I try to influence a balance, whatever that means lah. I'm trying to make sure your chemistry go up, but the rest either stays the same or also go up. That way, everybody is happy. That way, your LR5 is really increasing. Not chemistry go up, math go down, or I don't know, chemistry go up, Chinese go down, whatever lah, whatever it is. Okay, that's just my general approach. If you don't like it, I can focus on one subject. Make sense, then?
Yes.
Now, all these are made difficult by CCA. Now, I'll tell you my stand. I love people who do CCA. I love people who are athletes. There's a very good reason why. Afterwards, your stamina is very high. Right now, you're tired. I understand that. You will remain tired until the zonals are finished around February, right?
I think so, yeah.
And then after zonal, you hope to continue to, the nationals, right? Sorry, that's it, right? Zonals and nationals, that's it, correct?
Yes.
The nationals will last around, I don't know, around 6 weeks or so, something
I
like that.
think so, yeah.
Okay, and then by April, you'll still be tired because die, if you can continue, you die. You want to do it, man. You're the vice captain with a school with a good history in volleyball. Go, man.
Mm-hmm.
If your captain is injured, you will step up.
Oh, yep.
If you're injured, you will still attend.
Yep.
What else can I say? That is a spirit of an athlete. I support that because after you finish all your competition, your stamina will be sky high. That's the nature.
Mm-hmm.
And that affects a lot your ability to learn or ability to catch up or whatever that is. Okay? I'm happy
Yes.
because of that, right? Plus, I noticed that most athletes have very, very high grit lah. Okay? You have guts, you have grit, you have stamina. I like those things.
Yes.
Okay? So I support you, but at the same time, the consequences I have to balance with your CCA. There is no point if then I scold you, why are you sleepy today?
Mm-hmm.
Why haven't you done what I told you during this competition? As if I don't understand competition. I have my own share of competition. Right? Right. So right now, Sean, I'm gonna ask you a few questions first regarding this CCA. Would that be okay?
Okay.
Okay. Remember, I am supportive. Right now, I have a floorball champion last year. last year's global champion, now Sec 4. Pretty sure she will be doing a lot of important stuff again.
Mm.
Okay, and another this year, which one? Who else do I have? No, she's gonna graduate. Okay, right. Last year that was the basketball champion. Yeah, goodness me. Right. Okay. Do you still want to see your potential for O level by July?
I don't know. Should I?
How long can you delay it before you lose heart lah?
Um, I, I'm not sure.
Then I go back to the first question. Do you still want to see your potential? Therefore, have confidence, right? By July. Do you still want that?
Wait, like what does that mean? Like see where I am, like my like
No,
standard.
no. Let me try to make it very clear. Okay, like this, yeah, like this. Listen to me, listen to me. Right now, you're not confident with your chemistry, something like that.
Mm-hmm.
But chemistry seems important for L1, R5. Let me just confirm this is true first, or you don't know?
I don't know yet. Cause I take core job.
Yeah. So what does that mean?
Like I don't know if my chemistry like messes up. Like hopefully job will save it.
So your final spot in L1, R5 is either chemistry or geo.
Yeah.
The rest are quite fixed, right?
Yeah.
And A math will be included.
Yeah.
A math, bio, combined humanities, standard stuff, right?
Yes.
Okay, understood. Okay, so chem and geo. Okay, then I'll alter my question a little bit, right? Okay. You have some preference for chemistry, am I correct? That's why you're doing all this, isn't it?
Yeah.
Okay, may I know why you have?
Like over geography.
Yeah. Why?
I don't know, like geography is really boring. I wanted to take history, like core history, but my school doesn't offer it.
Oh,
Then like I was kind of scared that
yeah.
like my normal subjects wouldn't be enough, so I want to take a backup.
Mm-hmm.
But like I feel like geography is quite easy, but chemistry is like I don't know, it's more interesting, but it's harder. So I don't know.
Would you be happy if you end up taking geography in JC?
I don't plan to. I don't know. Like it's just really boring for me.
Would you be happy if you take chemistry in JC? If you
Um,
can and you have the confidence, lah. That's one thing.
yeah, but I'm like I'll be chill with it. Like I don't really have a strong preference right now because I don't really know what I want to do.
But if you're taking the science or hybrid, I'm sorry, have I explained all this to you? Do you know what I'm
Um,
talking about? You have your brother Ma Wang Rong. You should
oh
know what's
yeah,
going on in JC, ma?
I
No?
think so. Yeah.
Okay. So either hybrids, two science, two humanities, or three science, one humanities, or one science, three humanities. Can I confirm that you are not one science, three humanities?
Yeah.
Either two or 3-1. Make sense?
Yeah.
2-2 or 3-1, very likely people will take H2 math because science people have to take H2 math. But your A math is good, ma, no problem. Okay?
Okay.
Then very likely people take H2 chem or H2 physics. Taking H2 bio is considered very limiting unless you know what you're doing. No problem at all. No problem. If you know what you're doing, H2 bio is great.
Mm.
H2 math and H2 bio, and then you have two humanities. How does that sound? Have I ever asked you this question?
I think so. Like at the start.
Okay, what was your answer then?
Um, I don't know. I forgot.
You want to take history, right? Let's just say lah.
Yeah, probably.
Right? You do not want geography.
Probably not.
Econs?
I think so. It seems like a reasonable choice.
Okay, then I'm saying H2 math, H2 bio or H2 chem lah. And then H2 history, yeah,
Yeah.
H1 econs, something like that.
Yeah.
You'll be happy.
Yes.
It's a reasonable choice, right? So chemistry is always half-half in your heart, right? Half-half.
Mm-hmm.
May not have a future, may have, don't know, but it's just more preferable than geog, and you have to fill in your last slot. Are you sure there is no other option for the last slot of L1 R5 except chemistry and geog? Are you sure?
Probably because like my Chinese is like really, really bad.
Okay, bye-bye Chinese lah. Bye-bye Chinese.
Yeah.
Now talk about your potential lah. Now, so this is what it means lah. When I ask all my students, hey, do you want to see your potential not by July? Usually by the end of SA1. What I mean is this. When somebody does not have confidence, so you don't have confidence in chemistry right now, right?
Yeah. So.
It's almost impossible mentally for that person to set a goal. Like really honestly say, I want to reach a certain level. You'll be here and there. It's not an honest goal, even if you put it on paper. The reason is very simple, because a goal is something you have not achieved yet. It's beyond your capability, right?
Mm-hmm.
How can you set something beyond your capability right now if you're not even confident with your capability? How is that supposed to work? Not a lot of people can do that. People who can do that, I have no idea of my capability. I'm not confident in myself. I'll set a goal. They either really are, they know something we don't, normal people, or they have a bit of a loose screw here. Either way. Normal people cannot set an honest goal if they're not confident with themselves. This is clear first?
Yes.
This is how normal people works. Now, if you are to set a goal to win nationals, okay, that means you have certain amount of confidence in your team's capability and you're willing to contribute. Because you're a bit not very sure, then I'm saying that, okay, you have the confidence level to win zonal lah, but nationals, we'll see first lah. We'll see how much we grow lah, and that's fair. So what you're saying is basically, if I'm reading the line correctly, you want to find out your potential, or you want to be more certain of your potential, your team's potential, after winning zonals. Then maybe we can set a goal to win national.
Yeah.
Then that become an honest goal for you. Right now, it's just on paper. Maybe everybody else are on it, but you are not truly buying into that goal. You just want to contribute. That's okay, clear?
Yes.
I'm understanding this correctly, yeah? This is just how everybody process.
Yes.
Now back to your chemistry. No, so what I'm saying is, hey, do you want some changes? You want something happen, something significant happen, internally, whatever, through your exam, whatever, through this study, whatever, such that you have enough confidence level to actually set an honest goal for your O-level chemistry. Something must happen first so that your confidence level increase, usually a good performer.
Mm-hmm.
Then you suddenly say, hey, maybe I can do this. Maybe I can reach A2. Maybe I can reach B3. Maybe I can reach A1 by O level. That's more of an honest goal. That's what I mean by when the soonest you want to see your own potential so that you can set an honest goal. You clear what I'm saying?
Yes.
I'm going to add more information. Why is that important? Because it may not be important. I'm explaining something nice, but it's not important at all. I'll tell you why it is important. Because the moment a person set an honest goal, not just on paper, it is the moment a certain conflict ends. What is the conflict I'm talking about? When a person is not confident, let's say not confident with chemistry, don't know geography, I also don't like, but it's easier. He is not full-hearted, right? He's not of a, he's not of a united mind. He's not. Now, what will happen is very simple. There are only two ways. Either, hey, I'm not confident with myself, man. But I'm not willing to let go of my chemistry. So I put every bit of my effort in chemistry. I go very extreme. I die for chemistry. As a result, very predictably, everything becomes unbalanced. Put too much effort on chemistry, everything else becomes unbalanced. Your L1, R5 do not necessarily increase. This is not the way of most people, but I've known people who does that. Why are you putting so much effort? Yeah? This is too much already. The real answer is he or she is not confident with him or herself. Make sense?
Mm-hmm.
Somehow, my feeling is you are not this type for chemistry, lah, correct?
I think so. Yeah.
Then you're likely to do what normal people do. You are likely to do this. When chemistry feels a bit more solid, because of tuition lah, or because of whatever, because you understand the class, because you did certain small tests well, that's a good sign. Hey, your chemistry outlook is going up. That doesn't mean your confidence go up. It just means that, hey, things are getting better. Hey, my chemistry is not as bad as I think. Yeah? You know what will happen? You will reduce the effort.
Mm-hmm.
Because in the end, you are still not confident with yourself. Hey, but maybe that my trouble is not that bad. I would rather invest my time, effort, energy to things that I'm confident with. I don't know, A math, E math. Then you settle them more lah. You automatically reduce the effort. Then chemistry go down again, and then you put in more effort again. Just go up and down, go up and down, go up and down. If you don't think about what's happening inside, that is very likely to happen, and that is very likely what's happened to a person who decide to focus on one thing in tuition without thinking about it. Am I making any sense?
Yes.
If you don't think about it and your confidence level don't go up and I don't help you achieve a higher confidence level, your chemistry will go up, down, up, down, up, down, up, down. That's already a good scenario.
Oh.
Which is, some people will call it a waste of time, a waste of heart. You're not achieving much by the end. To avoid that, whatever, we do holiday tuition, blah, 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 I have my idea on how. The point is, I want you guys to achieve a very significant performance, whatever that is. So their confidence level really go up and say, hey, oh, maybe I can do chemistry. Maybe. Maybe you start to believe in whatever you have, whatever God has given you. And then you set an honest goal. And this problem will start to cease, will stop. This problem of going up and down will stop when you set an honest goal, when you have confidence in yourself. Do you understand what I'm saying?
Yes.
Therefore, that is the start of a very balanced L1 R5. And I'm telling you as a more like an L1 R5 coach. That is something I hope everybody experience, not after prelim, please. Be too close to O level. A lot of unnecessary suffering.
Mm-hmm.
That's the background. Am I making any sense so far?
Yes.
Any questions so far?
No.
And am I wasting your time?
No.
Now go back to CCA. I know you will be busy until early May. If you win championship, blah, 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 that will be it lah. And you will have a carry-on tiredness until mid of May, something like that.
Mm-hmm.
Okay? And then soon, whatever la WA, W2 comes, June comes, and whatever, it is still possible to see your own potential by July. I'm assuming the SA1 is in July. So because we have June, June is a good time to recover from your physical tiredness, from your mental tiredness from CCA, and of course, if you are left behind in any significant way in chemistry. So do you have June holiday? Unless you sabotage yourself in holiday, we have a good time there. Good time energy. Make sense so far?
Yes.
I certainly hope you don't have any other commitment in June holiday.
Yeah.
Okay. The second thing we already went through holiday tuition. As a result, your AMAT and your chemistry right now should be actually more solid the moment it enters those topics. So not very worried about it.
Mm-hmm.
Okay. Give me some time. I'm so sorry. Apologies. Now, no questions on it.
Yeah, no.
To summarize, you will put a lot of effort on CCA. Okay, clear? As a result, most of your studies will take a little bit of a step behind lah. That's just the natural consequence. Okay. Okay. A bit lagging here, a bit lagging there. So holiday tuition is already helping you lah. You won't lag too much. Okay. Because you can't do a lot of work after school. You'll be practicing a lot. Your energy will be spent. You're not very happy to hear that, isn't it, sir?
I think so. I don't know.
But sir, that is what is going to happen, right?
Mm-hmm.
Have you tried pushing yourself after a long week of training? Still
I
must
mean,
study at the end at night. Have you done that before?
yeah, but like,
And what is the result?
I don't know. It's like I just do like a little bit, then I'll get too tired, and then I'll go sleep.
Yes. Now, the question is, from my point of view, do you slap yourself because of that?
Um, not yet.
Do you plan to make yourself guilty?
Like,
Could have done more. I can do more. I have to push more. That kind of thing.
not like maybe a little, but like not very much.
I hope so. A little is fine. A lot is not good. That's not good at all. Because a person has a limited energy and you're focusing a lot of your good energy in CCA. If you don't like it, you stop your commitment. But I don't disagree with that. I don't disagree with your CCA commitment. I'm just telling you the effect for this 4 months. It will be like that.
Mm-hmm.
So if you want to thank God because you have went through quite a lot of AMAT and chemistry. So you'll be having an easier time keeping up. But you'll just probably keep up. That's all.
Mm-hmm.
And then after competition, when your energy level is high and it is not in demand, we use all of that after a recovery period. Yeah, you need some. We use all of that with June, bam, we prepare for your SA1. Let's assume that there will be an SA1 in July. That's the general plan or flow of things.
Mm-hmm.
Think about it right now. Tell me what you think.
It seems fine. I think like yeah.
You sure, son?
Yeah, I think so.
Am I speaking outside the boundaries of a normal tuition?
I don't know. This is like my first tuition.
True lah, but
I don't know. I'm sure it's fine.
okay. So that's all I want to say lah, right? Now I won't be pressuring you too much lah, right now. This is my way of showing support to your volleyball. Now, some people will be happy with that and some people might not feel happy with that. What do you want?
I don't know. I'm like fine with anything.
You're so tired you cannot even make a decision, isn't it? Right? Correct or not?
I
Right?
don't know.
You're in a whatever, man, right?
No.
That's what I mean lah, right? So I'll make the decisions.
No, okay.
Let's go with the flow for now, and I will start to demand more of you after the competition ends.
Okay.
Now, your mom is chill.
Mm-hmm.
Your dad seems chill also, as far as I can tell regarding academics. She's also chill. So I'll chill also lah. I don't see a need to pressure you right now.
Yes.
Clear, yeah? Okay?
Yeah.
Good. Now, okay. So let's talk in that thing, but you still have to answer that question, by next week. Do you want to see your potential by July? Yes or
Okay.
no? Okay, yes.
Yes.
So therefore, the cost is not that you have to force yourself right now, but you have to do maybe double work by after competition ends.
Mm-hmm.
Okay, that's the cost. Okay or not?
Yes.
Okay, clear. Good. If there are no more questions, could you just update what's happening in AMAT and chemistry?
A math we like did more differentiation. We did quotient rule, product rule.
All
And
the three. at this point. Good.
Like, yeah, we started the logarithm thing, but like that part I'm still a little confused, but I think I got it. And chemistry, like we're still doing electrolysis. We're like at the part like the difference between like the specialized cell or like the I forgot, but the two different type of cell and like the electroplating and stuff.
Go way down. So you are already at electroplating, right? Already.
Yeah, like we just did it today, but like it was for a while.
So that means you haven't actually talked about batteries lah. When they generate electricity. This one is when they need electricity. Am I making any sense?
I think so.
Okay, no batteries here. Okay, now you're tired. Do you want me to decide what to do or do I ask you?
You can choose. I'm like fine with anything.
Okay. For chemistry, I'll do for you exactly what I do for Nicholas lah. I'll explain the most complicated part and make it as simple as possible.
Okay.
Okay, so I'm giving you a skill which is very relevant in exam. In fact, I never talk about anything else. Whatever I talk about, I meant, okay, this is what you need to do in exam and it will make your life easy, blah, 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 blah. Clear?
Yes.
Take your paper and your pencil. You need to draw something. So draw for me, please.
Okay. Oh yeah, I got good notes on my iPad again.
So, okay, good. So I'm going to write it down. iPad, you get a good note 6 already, but but anyway, you never lost anything significant, right?
Yeah, I mean like I don't have the tuition notes anymore.
No problem. You just have your good notes, and are you looking forward to using good note 6? Is it something important to you?
Yeah, I think I'll use it.
Sure. So now if you want to write down in your good notes for now, let's just do so. That's up to you, right?
Yes.
But please draw something. So just draw these two things. When you're done, you tell me.
Wait, I need to sign in.
No problem. Do tell me when you're done.
Okay, wait, I'm trying to log in. Okay, I'm done.
Okay. Have you drawn these two?
Yeah.
Okay. In electrical plating, they introduce you to anodes and cathodes which can react. The anodes and cathodes are no longer graphite, and no longer platinum. These two things are very convenient. They conduct, but they don't react. So it saves us trouble. Clear?
Yes.
So give an example. Anything else other than these two, you have to think more. I'm here to teach you what is the best way to think about it and how to make it as short as possible, right?
Mm-hmm.
Please notice that the battery is reversed. According to your knowledge, should there be a difference?
Yeah.
Then let's see what's the difference. Now, right now, sir, if you can figure out the two reactions, they call it two half reactions, then I don't need to teach you anything anymore. Can
Oh.
you figure it out?
Like for the iron and copper.
I'll give you the electrolyte also lah. CuCl2 easy, CuCl2 easy aqueous.
Wait,
You
I need
can
to know
figure it out.
like if it's dilute or concentrated.
Sure. Dilute.
Okay. Is it the copper like loses electrons?
Okay. Now I'll write at Fe and Cu. Yeah? You're saying that at Cu it loses electron. I'm so sorry. I'll write it down. Lose electron. Okay, then.
Then like it forms Cu2 plus. Then like at like the iron, then it is it gains? Wait, no, I don't think that's how it goes. Is this the one where like the thing dissolves in the electrolyte?
Hmm. Are you sure about something, or you're not sure at all?
I kind of forgot like the different types.
Okay. Now, my method is most of the time understanding based, meaning whatever they throw at you, you can answer it. I think that's the best way to gain confidence, not to memorize. Are you good at memorizing, by the way, sir?
I think so. I take like bio, history, and geo, and they're all memorizing.
Oh, yeah. Would you believe me if chemistry is 80% understanding and 20% memorizing?
Yeah, last time I memorized all my notes, then I failed.
And you are very, very sad, isn't it?
Oh, yeah. I don't know, I was just a WA.
But hey, you are right, sir. If you consider, normal people will consider it this way, 50-50 lah. So if I memorize, I'll get 50%, I'll pass lah. A bit of understanding, I'll get more than pass. That usually never happens. But that's because I think in nature, chemistry is 80-20, 20 memorize. Okay, so brace yourself with some understanding. It's very difficult to understand things when you're tired. But I'm not pressurizing you. I'm just slowly explaining to you. Would that be okay?
Yes.
Now, the most important thing is the electron flow. The most important thing. The first thing you do, the thing that matters. Okay. Bottom one. Please check for yourself whether the electron flow is correct or not.
Yes.
I'm wrong somewhere.
Oh. Is it like the below one? Is it positive to negative?
Do you need explanation or do you know that I'm wrong?
I think I know. I think my teacher just said today.
Good. Hopefully you and your teacher and I have the same thought. Hopefully.
Yeah.
I'm so sorry. So the electron flow is now like, will that be okay?
Yeah.
Now, just because of that, we have everything we need. I'll show you. Now, at Cu, definitely we are gaining electron. Come on. Look at the arrow. The electron is being pumped into Co. Must be lah. something happening in Cu must be gaining electron lah. And therefore this must be losing. It's so obvious from the electron flow. I'm trying to not ask you to memorize that. I'm trying to show you. Do you see it? It's obvious.
Yes.
At the bottom side, at Fe, is it obvious?
Yes.
What is it?
It gains electrons and copper
And
loses.
I don't know about you. Your memorization skill seems good lah. I believe you that my memorization also is good. But I go crazy if I have to memorize these details. I would pretty much rather understand it.
Mm-hmm.
Okay, your choice, but I would strongly suggest understanding. Now, gain, lose, whatever. Notice that I don't care who is anode and who is cathode. As far as I can tell, it doesn't help much.
Mm-hmm.
Okay? If you want to know, very easy lah, but you tell me. Now, the thing that makes this example complicated is that there are so many candidates. There are at least 3, sometimes 4. What I have done, electron flow, blah, 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 is not the thing that makes it complicated. That's the thing that you have to do for most electroplating or electrolysis, okay? Now, candidates, let's see whether your teacher talks about it or not. Now, please understand, because Cu is forced to gain electron, what will happen, electron is pumping there, he will attract positive things. And that is also something more like a common sense. Does that make some sense?
Yeah.
This one will attract negative things. That makes some sense.
Yeah.
And there are more than one positive thing. There are more than one negative thing. Okay, so what are they? The positive thing is, well, Cu2 plus, Cl minus, Cu2 plus. There you go. Got it?
Mm-hmm.
Its aqueous is dilute. There's a lot of water, so it will also attract H plus. Am I making any sense?
Yeah.
Is there anything else to attract positive things?
No. Like other than the iron.
No.
Oh.
But we have to put in Cu on the list because Cu may react. That's the complication. We have 3 candidates at least. Can? Does that make any sense to you? We have to consider it at least.
Mm-hmm.
Okay. Now, what are the candidate lists for the top one? You know, the Fe loses electron, attracts negative stuff. So what are they?
Wait, I think like the screen is here. I can't see like.
Are you zooming in the screen? Because I'm seeing my own screen and everything can be seen.
Wait, let me check. Okay. Oh, okay. Okay.
Am I making any sense? Is this tree okay?
Yeah.
Yeah. Then we make a candidate list for the one on top.
Mm-hmm.
Okay. Attracting negative things. So what are they?
Cl minus.
Well,
Fe minus.
there is no Fe minus.
Oh, Cu minus.
There is no Cu minus. Come on.
OH minus.
From the wall. Okay. Anything else that may react here?
The iron.
Yep. At least put that in. At least put that into the list. Okay.
Mm-hmm.
Okay. Now, who wins and who lose? Does your teacher talk like that?
Yeah, like I think so. Yeah.
Okay. Then, if you have some knowledge, you can at least make a guess lah. Whatever it is, however you process it, tell me, who do you think will win?
The Cu2 plus below.
Okay.
And
Then,
on top it's Fe or is it OH?
which one?
Okay,
Which one?
I think it's Fe.
Okay. My choice happens to be the same. I know the reason why. Now, Sean, if you are very certain about this and you cannot be shaken, there's nothing else I need to teach you. Really nothing else. You got it right. But how certain are you?
I'm like normal, slightly below average.
Okay. Now let's talk about the bottom one. This attract what?
Um, the Cu.
Okay, again positive, attract positive lah. So Cu what? Cu2 plus, right?
Oh yeah, Cu2 plus.
Right.
H plus.
Mm-hmm.
Iron.
Mm-hmm. Okay, so attract negative one. So
Cl minus, OH minus, and
okay. So who wins?
on top is the Cu2 plus.
Mm-hmm.
Below is OH.
Okay. So pink is my choice lah.
No.
Doesn't mean I'm right, you know. That
No.
doesn't mean that at all. That means I have a reason lah. I'm more convinced. Can share the reason with you. Okay. Now, do you want to do that?
Okay.
Okay. Now, reactivity series. Your teacher will have introduced you to the two reactivity series. Now you have two, the metal one and then the other one.
Oh yeah.
So, very easy to use. I teach you the simplified version, triple dot, triple dot, triple dot. Understand?
Yeah.
Plus, there's a mirror image. The image plays a very important part in explanation. That's what you want. The mirror image will contain all the positives, right?
Mm-hmm.
Okay, and then this is C4 plus, and then dot, dot, dot. Now, the other one, I'll do the complete one, is shorter and simpler. Don't write the negative on top, write the negative on the bottom. So, F2, Cl2, Br2, I2, and then O2, something like that lah. And then you have your OH minus here, your I minus, your Br minus, Cl minus, and your F minus. Am I making any sense so far?
Yes.
Okay, now look at what we are different. Let's just look at where we are different. Okay, which is this one. Now let's look at the candidates. The candidates are Cl minus. Where Cl minus? It's here. It's not on top. Do you understand? The top one is Cl2.
Mm-hmm.
There's your candidate, another candidate, OH minus. Just from that, I already like your choice. OH minus must jump up and Cl minus must jump up. Lose electron, ma? Lose
Mm-hmm.
electron become less negative. That's a jump up. Jump up requires effort. You choose the guy that requires less effort. Good job. Understand?
Yeah.
Why does Cu win? I have to explain that to you. Very simple. Where is Cu? Tell me.
Below Br.
Nonsense. It's here.
Oh.
This is Cu2 plus. Please understand that. The positioning matters a lot. Can you accept this?
Yes.
The Cu is here, not there. And when Cu loses electrons, Cu become 2 plus. Nothing special there lah. You know this reaction and whatever not.
Mm-hmm.
There's only one thing that makes me correct. This is a jump down. A jump up requires effort, no matter how small. A jump down, well, does not require effort at all. It actually gives off energy. People call it a voluntary process. It's very easy thing to do, whatever. This is a jump down versus a jump up. You tell me who wins.
Jump down.
That is the very informal but always correct explanation.
No.
Would that be okay?
Yeah. Wait. Like my teacher told me something about the concentration being like different, cause like she said like if it's like dilute and concentrated, then the answers will be different because there is yeah. So
Let me
like
show you. Let me show you.
okay.
He's talking about, for example, OH minus and Cl minus. Now, by right, OH minus always wins. By right, because the jump up for Cl minus is just way higher. Fair enough?
Yes.
But if it is concentrated enough, then isn't concentration simply mean you have more Cl minus, you have less water, something like that lah.
Yeah.
So the Cl minus starts to get more and more crowded. The OH minus start to get less and less crowded until the fact that sometimes there is no OH minus available. sometimes. Near wherever the reaction is. In this case, near Fe, or in this case, near Cu. The Cl minus can win by crowding, is all he's trying to say. So even though the jump up is very high, if you don't have OH minus, there's only one candidate, Cl minus. So Cl minus wins lah. But you know, OH minus sometimes sneak in, even though there is less of it. And when he sneaks in, he will win. Actually, that is what happened. They alternate, but for the sake of simplicity, you simply say Cl minus wins. How do you say it? So when it is concentrated, Cl minus wins become Cl2, correct? Don't forget, your teacher continues up, but because Cl minus wins, the concentration drops what? You're removing Cl minus what? The concentration drops. What happened? Water starts to win, OH minus start to win. And then the water drop, and then Cl minus win again. It'll take turn one, actually. Some teacher explain, some teacher don't.
Oh.
Do you understand? I'm explaining because it makes sense, not because I'm trying to complicate your life.
I get it.
Okay? So that is without the third participant. When there's a third participant, you have to consider the third participant before you declare who wins. The dilute concentrated example is usually graphite or platinum, simpler life. Okay, when you have a reactive metal, please consider it. Now, are you taking notes? Are you writing anything? What do you want?
Yeah, wait, I'm writing down like the reactivity thing on my iPad.
That thing. Tell me, I've never met a teacher who draw the mirror image. Maybe your teacher also draw the mirror image? Who knows?
No, she just show us the textbook and like in the year one is like the first group metal, second group metal, third group metal. Like in our textbook is like the specific metals with
Correct. Which is of course important, right? Until you
Yeah.
realize in electrolysis, none of them will be used
Oh, okay.
because they are very dangerous metals. So they'll be used in other examples, definitely not when you're dunking it into water. Those group 1, group 2 metals are just dangerous. So it will be there, but for electrolysis, we don't worry about it too much. I'm gonna get some tissue. Sorry.
Okay.
Okay, tell me when you're done, yeah?
Okay, I'm done.
Okay. Are you sure this is not making your life more difficult?
I think I'll get it.
Okay, so one more time, the electron flow is the start of everything. That's the first thing. The candidate list, I will strongly suggest you write it down. The more complicated the question, is just easier if you write down the candidate list. Thirdly, most of the time, you should have reactivity series for other questions. So once you write down one, you should be able to use it multiple times. Right lah. Okay. Might as well, I teach all my students during before prelim, just write this down at the start of the paper lah, at the first page something. You'll keep using them and that's for your benefit, something like that. So 1, 2, 3, you use them, anything you should be okay. Are you sure you're okay for now, sir?
I think so.
Okay, now tell me, is this electroplating or not?
This?
These two examples, are they electroplating?
Um, Don't think so. I thought like
Okay.
there needs to be something.
Okay, the word electroplating actually means something simple. You're gonna plate stuff with the help of electricity. Okay.
Mhm.
Well, we have the electricity. It's just battery. Nothing fancy, nothing high voltage, nothing dangerous. You can do this at home. And you're plating something by a metal. Usually you can only plate things with metal. Now, let's see what happened because determining who wins is only half the analysis. There's so many effort involved in the electrolysis question. Some people just don't like the amount of effort. But you don't seem to be the type that is afraid of hard work lah. Okay. Now tell me if you do or tell me if you want to stop right now. Tell me when it gets too heavy. You understand me?
Yes.
I know that you're tired. Okay. It is my support for you. They will. This is the easier part, by the way. The second part is giving you more marks. So you describe your observation. Okay, some people think of it as, oh, wow, that's harder or that's a different kind of question. The way I see it is just a very normal follow-up from this. I don't need to do anything else. I just have to write down what I think is happening. To me, that's bonus mark and I'm more than willing to get it. I'm actually waiting for the second part. And most of the time, they do ask that. Yeah. So now, when you know who wins, by right, you can write down the reaction. When you write down the reaction, everything is clear and done. Can you write down the reaction?
Um, don't think so.
Okay. Now let me get it straight. You know who wins. You're quite right, lah, I suppose. Maybe you memorize or whatever, but you cannot write the reaction at all.
Like the one with the electrons or the
Okay, I'll
full
just
one.
show you. I'll just show you. No, no. It's always half-half. You don't
Oh,
need to
oh,
write down the full one immediately, nor is that the right thing to do, nor that is a sensible thing to do. You always write half-half.
oh, okay.
And the
Don't
half-half
think
is very
so.
easy one. Can you do that?
Yeah.
Okay, you write down. I'll show you my answer when you're done.
Okay.
Okay, you have 1, 2, lah, right? You have half, 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 half.
Mm.
Tell me if you're done or if you're stuck.
Done.
Okay. So I'm gonna write down 4 half reactions and you compare, okay?
Oh, huh?
Why 4? Because this one wins, right? Right? This one wins.
Mm-hmm.
So the reaction is, again, from the initial step, I already know what the reaction is. Oh, this reaction will lose electron. Is that right? Oh, very easy lah.
Mm-hmm.
Losing electrons will look like this lah. If you don't understand or if you have any doubt, please tell me. Let's assume it's 3 plus lah, easier. Okay?
Oh, okay.
And never mind 2 or 3 plus, we don't have to worry about that. Now, there's another guy low. So we say that this guy wins, right? This guy wins
Mhm.
by gaining electron. Again, not that difficult also. Gaining electron is as simple as plus 2 electron equals to Cu lah, right?
Yeah.
You're supposed to combine them. You're supposed to balance the electron. We're not going to do that right now. Okay? I'm going to do something else. I'm going to ask the normal question, an exam level question asked. What's the observation? And related to that, is this electroplating? Because I think this is clearly electroplating. I have to at least explain why first lah. Okay? Would that be okay?
Yeah. Wait, but how do you know it's electroplating?
Okay. Electroplating is plating something with the what do you call it? With the what do you call it? With a metal lah, with a metal, right? So let's
Mm-hmm.
see whether that actually happens or not, right? Okay. So our observation is very simple. Look, yeah, our observation is truly simple. I'm so sorry. The Fe, the Fe metal will reduce its mass or slowly disappear or whatever. Isn't that obvious?
Yes.
The solution will get more and more reddish brown because this guy is reddish brown. Also obvious, but
Yes.
it's too obvious already. You just mentioned that, okay, you're halfway done. It's too obvious. It's a
Mhm.
result of a good analysis. Now we look at the next reaction. The next reaction is, oh, for some reason, well, this is the reason the solution will lose its blue color. Obvious what?
Mhm.
Correct? And this is at Cu. Cu will be plated with Cu. Then you will say, oh, Cu will increase in mass. Or more Cu, I'm so sorry. More Cu will be deposited at Cu. Whatever lah, whatever how you phrase it, that's it. For now, isn't that electroplating in some sense?
Oh.
Isn't that I'm plating Cu with more Cu lah? Not sure whether that makes sense or not, but that's I'm plating something with something, at least.
Oh.
Correct? That's all
Yeah.
what electroplating means. There's nothing special besides, oh, something's happening there.
Mm-hmm.
Okay. Now, people won't call this electroplating. People will call this more like purifying Cu because obviously plating Cu with Cu doesn't make practical sense. It's already Cu. What? Why are you plating it with Cu? Oh, the answer is I'm trying to purify the Cu. The Cu that is plated on top of Cu is extremely pure. They like pure Cu. Do they tell you why?
No.
That is what you need to make wires. The wires that is the Cu used to make wires has to be extremely pure. It can only be done with electroplating, so wires are a little bit expensive.
Oh.
Okay. But electroplating and purifying Cu is so similar, lah, if you like.
Mm-hmm.
So similar. Am I making any sense, then?
Yes.
Am I saying something new?
No. I just didn't know there was electroplating because I thought like they have like a random object, you know.
No. No. In this case, the object is another Cu. Whatever, like is whatever.
Yeah.
Okay. So far so good, yeah?
Yes.
Yeah. Now that Cu can be replaced with a random object because the Cu turns out to not matter, right?
Mm-hmm.
So I can replace it with something that is conducting. You cannot replace it with something plastic. Tell me why?
Because it will be an open circuit.
Correct. It will not conduct electricity. Very smart. Okay. Okay. Now look at the bottom one. Have you done the reaction? And then you tell me whether there's what's the observation, whether there's an electroplating or not.
Um.
First, do the reaction. Nothing
Oh.
else.
Um. like Fe2 plus.
Who wins? Who wins? This guy wins. You said it yourself. This guy wins.
Oh,
The
okay.
bottom one. Okay. So the reaction is
Cu2 plus 2E minus equals Cu.
then I show you that this guy win. Remember, jump down always wins. So
So Cu equals to Cu2 plus 2E minus.
okay. Now observation, please.
The Cu will decrease in like mass, then
Okay,
like
nice. This one.
it will dissolve into the
Perfect.
electrolyte.
Right, sure.
And then the other Cu will like
There's no other
increase.
CU. There's no other CU.
Or like the is
FE.
it Fe? Yeah, the Fe will increase in mass and size because like the Cu
Will be
will
deposited
be
into it.
deposited.
Okay. The phrasing not the best, but you get the idea. Clear? That's
Yeah.
what's important right now. Is this electroplating?
Yes.
It is. Now, what's the difference between the top electroplating and the bottom electroplating?
The direction.
Explain to yourself.
Like one is like from
Let's just tell yourself the top one electroplating who, the bottom one electroplating who.
oh okay, the top one is Cu electroplating Cu. The bottom one is Cu electroplating Fe.
Which makes more practical sense, I guess.
Yeah.
Now, the top one has one more problem.
No.
The Cu2 plus from the solution is not replenished at all. And the bottom one, the Cu in the solution is being replenished, extremely important.
Wait, what is replenish?
You notice that the Cu2 plus is being used.
Yeah.
So it'll run out lah.
Oh yeah.
But hey, it's being replenished
I get it.
by the Cu solid, which is great lah. That's what it is for. You set up the battery wrongly. Now you can say with some certainty, hey, the top one, the arrangement not so nicely. First of all, I thought it makes more sense to electroplate the Fe. Makes more sense, man. Correct or not? I'm not doing that. Secondly, the Cu2 plus is being used, but it is not being replenished. See? It's not being replenished.
Oh.
It's being replenished by Fe3 plus. So I don't have Cu2 plus after a while. Do I change? I get a different result after a while, which is very weird unless that's what you want. You can roughly say the top setup is wrong in that sense. The bottom setup is better in that sense. Whether you want to memorize that or not, that's up to you. But I always suggest look at the reaction. Everything will be clear.
Okay.
Does this make any sense?
Yeah.
Okay. This is not the most complicated example, but this is close to the most complicated example. Okay. Are we at the level of your class?
I think so, yeah.
All right. Do you want to ask more questions?
I don't know.
Okay, now I'll give you the options. You still must do some choices. Yeah. Now I can show you even more complicated looking example of electroplating that not electroplating, electrolysis that actually exists in exam. It's crazy. Okay, that's one option. But that will be the maximum. I think there's only one more level. So maybe that's a good news.
Okay.
Or we can go to what I told everybody. Hey, in the electrolysis chapter, electrolysis is not the most important one. The important one is the other half, the one that talks about battery. Actually, that is more popular in exam. I don't know why. It's also easier. I don't know why. But people get confused between both of them, which is very dangerous.
Is that the voltmeter one or no?
Yeah, the one with voltmeter. The one that should have been much easier, but people just get out of whack. Just don't know what they're thinking.
Oh, that's the one we started doing today.
Must be lah.
Yeah, but like
I
I don't know.
Say something.
I don't know, like we covered like very little.
Yeah, but that is the more popular one in exam. I guarantee you. It's obvious. Easier, more popular, and people get more confused. Okay, so you already have that two options though. You can go the highest difficulty of electrolysis, or you can talk a lot more about the battery one, which means we are going forward from the class. Always a good idea.
Okay, let's do that one.
Okay. Are you tired?
I'm like I'm good. Like yeah.
Okay. Your energy level is out of 10?
7, because there's no school tomorrow.
Oh, very happy.
I know, right?
Oh, happy day. Happy for you. Don't tell me you have training tomorrow, okay? Just don't.
I don't have.
Yeah, do not tell your captain go away. Okay? Captain, go away.
Yeah.
For now. Okay, I will not support you for this one. Energy level. Hey, tell me, during holiday tuition, what's your energy level?
I don't know, like 10, like normal. Depends on how much I slept.
10 out of 10, really?
Yeah.
Mm,
Ready.
I like 10 out of 10. Anyway, so the battery one, right? Call it battery. Now, the fancy name is called cell. This is a superbly dangerous word because they also call electrolysis cell. It's very annoying. Don't ask me why they even call it a cell. I guess I know why, but it's not very helpful at all because they are opposites. They're supposed to be opposites. Okay, this is your power bank. This is your power bank in use. And this is power bank charging, as in being charged. Obviously, they are doing a different function, right? Your power bank is being charged. It's very different from you're using your power bank to charge your handphone. This is clear, yeah?
Yeah.
And yeah. Now, they call both cell. Hey, I mean, a power bank is a power bank lah. So calling them both cell makes some sense, except that it doesn't explain anything. But if they just use the word only cell, not electrolysis cell, they actually meant the battery one. This is not good. This does not make a lot of sense. It complicates things. Just want to say that. Okay.
Yes.
For the rest of the thing, it is better to rely on the picture. Now, one thing good about this chapter is there will always be picture. Always, 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 and they will give it to you. You just look at the picture, you should know immediately this is which one. As you can tell, the one with voltmeter means the one with no battery, right? Simple one. The one with battery is electrolysis because electrolysis requires a power source. Make sense? If there is no power source, it's a voltmeter, whatever, man. A voltmeter is not a battery. It doesn't give off electricity. So this must be the battery itself. This one requires battery. This one is a battery to other people, to the voltmeter or whatever not. The voltmeter is a representation of the devices you can use to put here. So this can be a lamp. This can be a lamp. Why? Because yeah, you use battery to power a lamp, right? It can be your handphone. This can be a lamp. This can be a laptop and whatever not. This can be a smartwatch. Make sense?
Yes.
Now, the confusing part is that the drawing is now exactly the same. If you're not confused with this, I don't think I need to explain to you much. Are you confused?
Like with the drawing.
The drawing is exactly the same except for the voltmeter and the battery.
Oh yeah.
Secondly, there is almost no battery with carbon or platinum. Almost none. The last battery they talk about will look like that, but the moment you see a battery, you do not hope for graphite or platinum. You hope for normal metals. Normal metals. So I'm going to put Fe and Cu again. If you see Fe and Cu in electrolysis because of the battery, you will think, hiya, candidate this la, that la, very long thinking process. Hiya. You see battery Fe and Cu, very easy. Very, 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 very easy. In fact, if you see graphite or platinum, you'll scratch your head. Wait a minute, I don't understand how this battery works. Okay, now, are you ready for the battery?
Yes.
A battery is supposed to do this. Now, at least as a chemistry student, you must understand this. A battery is supposed to change chemical energy into electrical energy. An electrolysis do the reverse lah. Electrical energy, because it requires battery, into chemical energy. Would that be okay?
Yeah.
Now, once you understand this, you will immediately expect one of the metal to be consumed. That is the immediate start. People don't understand this. The immediate starting point of a battery is that which metal is consumed. Remember your leaking battery. You have leaking battery?
I don't have.
Okay, good for you. Have you ever had a device being damaged by leaking battery inside?
I don't think so.
We live in different world and different era. Go ask your mom. Okay, so
Okay.
anyway, so a leaking battery, do you even know that a battery leaks?
Yeah, because of
Okay,
the picture,
because of what, sorry?
the textbook.
Ah, right, because of textbook. Make me feel old. Now, a battery leaks because its casing is being consumed. Make sense?
Mhm.
The casing is one of the metals. The metal is being consumed. Ah, battery leaking, no? Simple. It leaks out the electrolytes. By right, the electrolyte is being encased by the metal. Doesn't look like it here, but they designed the battery like that one. Okay, so the metal is the casing and the electrolyte is kept inside. One of the metal is being consumed. It's extremely easy to tell which one is being consumed as the first step. Do you know who?
No.
Okay, remember your reactivity series.
Oh.
Hey, that guy again. Hey, hey, hey. Hey, hey, hey. Identify where these two candidates are. The candidates are only Fe and Cu, correct?
Mm-hmm.
Reactivity series is so simple to write down. CH mirror image, right? Triple dot, triple dot, triple dot. So easy. Where is Fe and where is Cu? On the top mirror image, bottom mirror image?
Fe is below.
It's here.
Wait, no, Cu is below hydrogen.
Very good.
Fe is
Over there.
below zinc.
Correct. Which is zinc is here. Good. And both are on the top mirror image, not the bottom one. Correct?
Yes.
If they are to react, because being consumed means they react. Make sense?
Oh, okay.
Both will jump down. Now, how can you be consumed without reacting? Doesn't make sense. Both will jump down. They both will jump down. That's why it's an automatic reaction. They want to jump down. Okay?
Yes.
Who will win?
Cu.
How can a smaller jump down win from a bigger jump down?
Okay. Fe.
Correct. We'll be afraid of heights. We don't want to jump down. It's too high. Fe is very different. I jump lah. Fe wins. Therefore, Fe is being consumed. That is the first step. First step. First step, you immediately write, oh, Fe is being consumed like that. If you don't get this logic, we restart this all over. This is the first step. That's it. This is a totally different first step than the electrolysis. This needs to make sense, I hope. Are you okay, sir?
Yes.
You sure?
Yes.
Now, this first step almost clears everything already. It's almost done at this point. Look at this gives off Fe3 plus and 3 electrons, correct? Electrons do not want to go to the solution. It cannot dissolve itself. So you go to the wire, correct?
Mm-hmm.
And then the Fe3 plus will go not to the wire. It cannot go into the wire. It will just go into the solution. Easy peasy. Okay.
Yes.
Now, the solution is something else. Can you accept that the solution is the other guy reacting? It won't be Cu. It won't be Cu.
No.
Okay. So, because Cu cannot accept electron, Cu will never accept electron to become Cu minus. Never, 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 never in their life. Never.
Mm.
So it must be something else receiving all this electron pouring into Cu, and this will be the guy in the electrolyte. The electrolyte can be anything. You just randomly choose for us.
NaCl.
Sure, an ACl, right? Okay, which is aqueous, right?
Yes.
Which is minus, which is plus. Now, look, it's very easy lah. Who will be there to receive the electron?
Cu.
But Cu will not actually absorb the electron to become Cu minus. It will just let him pass because there is no way Cu is going to do this, right? So
No.
what is the next candidate to receive electron?
Na
Plus, don't say Na.
plus.
Na plus or H plus, don't forget.
Oh yeah.
Okay, now look at the reactivity series. Where is H plus? It's here.
Mm-hmm.
Where's Na plus? It's down
On
here.
top.
No, 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 no. The one on top is Na. Stop saying that.
Mm.
Na plus is way at the bottom. Get used to my reactivity series, which gives you much more understanding. Please, please, I beg you. I'm not joking here. H plus is here, Na plus is here. Who will win? Who will win?
H plus.
It's obvious if you know the jump up and jump down. Jump up, jump up only possible with the mirror image. H plus and E plus. So this guy will lose. H plus will win. Receive electron becomes
Oh H.
H2.
Oh H2.
The battery reaction is done. Some people are extremely confused by this. Some people call this easier than electrolysis. Let's see which one you are.
Wait, but why does the Cu just let it pass?
Okay, right. First of all, Cu conducts electricity. So it's fair to say the Cu let it pass. It's not a wrong thing to say, Ken.
Oh yeah.
Now, however, Cu has the first option because it passes through him. If he wants, he can absorb the electron if he wants to. So it depends whether he wants to or not. He has the first priority. Make sense?
Yes.
And this first priority guy, Cu metal, look at electron and say, bye, I do not want you at all. If you don't understand this, we go back to Sec 3, the very basic thing about metal. The life goal of a metal is there's only one life goal for every metal. That's what you learn in chemistry. What is their life goal? For every metal, they want to
Yeah.
achieve, correct, not correct,
Oh.
react so that the reaction is not the life goal. The reaction is the means to achieve their life goal. Their life goal is to lose electron to achieve a noble gas configuration.
Oh yeah.
Now, notice that metal never gain electron because they always have extra electron.
Yeah.
So you are proposing to the Cu. I propose to you, Co. There's so many electron passing through. Go and get it.
No.
He do that. It is the total opposite of a metal's life goal.
Oh wait, then why the others can?
No metal can become metal negative. No metal can become metal negative.
No, like why in the other example, like the one just now, then Cu can react.
Look at that.
Oh
You
yeah.
are
Can.
totally misunderstanding. It's not Cu becomes Cu minus. It's Cu2 plus becomes Cu.
Oh,
That is
okay.
a reverse of a life goal, but it's not as bad as becoming Cu minus. Because Cu minus is totally unacceptable already. No, look. Cu2 plus becoming Cu is already a reverse of a life goal. How do I know? It's a jump up. He doesn't like it actually. He wants to become Cu2 plus. You're asking him to revert back to Cu. He does not like it, but he can still accept lah. In this situation, you're asking the Cu to become Cu minus. Not gonna happen in his lifetime. Just not gonna happen at all. Either you memorize this or you understand this as what the metal wants and do not want. Something like that. Something like that. That's the best way I can explain it to you. No metal wants to become metal minus. No way. Just no way. A metal ion, however, can receive an electron if you force him to. He will oblige. He will oblige lah. Do you understand what I'm saying?
Yes.
You very sure?
Yes.
If you think like this, nothing will stop you. You will understand everything, electrolysis, and in this case, battery throw at you. Everything. Guarantee you. Now, this is 902. I, by right, still need to give you one examples to figure out whether you can or not. Can I do that?
Okay.
Okay, the example is battery lah, of course. The question is, can you figure out the two reaction? Understand?
Okay.
One more time. The first step is to figure out which metal reacts because only one metal reacts. First step. The second step is to figure out what happens in the second reaction. I usually call it two-step. People can think about it differently. Okay?
Okay.
So a battery is very simple. You have a voltmeter. Hey, no battery outside, so voltmeter lah. And then you put two metals. Two random metals, please.
Zinc.
And
And copper.
copper. No, zinc and Fe.
Oh, okay.
Okay, it is possible. Any battery can do that. Now you determine a random electrolyte for now. Just random one.
Sodium chloride.
So no, something else different. Come on.
Calcium chloride.
Sure, calcium chloride. Yeah. Okay. Now your question is, can you figure out the two reactions? Go on.
Okay, so the first one is zinc.
Zinc will do what?
Like will react first. Like the electron.
To become?
Zinc 2 plus.
I don't know your reason, but you're correct. Okay, then.
Okay, and then next one. Wait, CaCl2. The next one is, wait, let me check. The next one is hydrogen. Again, like 2H plus 2E minus equals H2.
To show you whether you're correct or not, you have to draw the electron flow. By the way, some question ask the electron flow lah. I hope this makes a lot of sense to you. Okay. And this one, there is a Ca2 plus and H2 plus lah. And you determine that H2 plus, H plus wins. I agree with you. Usually at this stage, all that's left is to combine them, but combine them is the easy part.
Oh.
For now, you have figured out basic batteries, and more batteries are very basic. Just like that. They will ask you for observation, of course lah. Hey, what's the observation? Come on. You know the reaction is so simple, right? The zinc metal will be consumed. The zinc metal will reduce in size. You know, the solution will blah, blah, blah. And then there'll be bubbles forming at the Fe side because of hydrogen gas.
Yes.
Nothing complicated at all once you know the reaction. You understand?
Yes.
Now, your teacher will explain to you the final form of a battery. The final form of battery is what they call the fuel cell. When they say fuel cell, it is extremely misleading. For some reason, what they call fuel cell is hydrogen gas in, oxygen gas in. You have graphite, and you call this a battery. It's extremely confusing. And yet, your teacher will very likely explain this as the last part of the battery. This one is supposed to be easy to understand. This one is supposed to be rather confusing. No time for today. Just saying first. Anything else, sir?
No.
How do you feel for today?
I feel good.
Good, son. For now, enjoy your CNI and hours.